everyone. Isn't this the coolest place for a talk ever? It's surely on the top of my list. I love this place. Okay, so the state of Kubernetes development tooling. So if you're here, I'm assuming you're a developer and you've tried working with Kubernetes, and it was maybe not exactly what you wanted because, it's hard. Luckily for us, there's a lot of tooling available to help us. But unluckily for us, there is a lot of tooling available. So we're gonna, find our way through this jungle and try to make sense of things. And specifically, we're gonna see about tools for developers working on apps that run on Kubernetes. So if you're writing stuff for Kubernetes itself, like CRDs, controllers, operators, all that kind of crazy stuff, this is not exactly what we're going to talk about. We're going to talk about you working on your application for your business, for your company to do your stuff, and it just happens to be running on top of Kubernetes. We're going to specifically address the pre-commit workflow, because I think we have enough stuff in terms of CI and that kind of stuff, GitOps and all of that. We're going to look at the pre-commit workflow, about the part of your day where code gets written, about your own workflow of writing your code. Does it work? Does it not? Do I need to refine this a bit? Or, that kind of stuff. How are we going to do this? I'm going to look at a bunch. When I started with this, preparing this talk, I looked at all the parts of the development stage that we normally go through. And I decided, okay, so let's focus on what I'm doing on my computer as I'm writing my code. So let's strike some of those off. So I don't care about provisioning. So, Terraform, Pulumi, Minikube, Docker for Mac, those are different questions. We're not going to look at them today. And the same for what happens after you push a commit. So CI, CD, observability, all that kind of stuff, we're not going to look at that right now. So there are three different stages that we need to be concerned with. The setup, so the stuff, my config files, and maybe I'm gonna work on an application that requires a database, and before I can play around with my application, I need to put some tables in the database, so that's what I'm calling bootstrapping. Then there's the development cycle, where you write your code, build, deploy to your development cluster, and see what happened. And then there's the feedback, which is the see what happened. So when you either test things manually or some tests run, and then you debug your application in some way or another when something it doesn't work quite how you want it. So I made a wish list for my, my ideal development workflow before I looked at any of the tools. And so what do I want? I want config files that are manageable. So Kubernetes manifests, I don't like working with them. They are too long, too detailed. I don't need that level of detail when I'm working on my application. I need them when deploying to production, but that's a different story. If some tool is going to create config files for me or make them not necessary, that's a big plus. Again, there is setup tasks, like I mentioned, to populate a database before I can test my service, that kind of thing. Then there is the development cycle. And so I don't want to have to type Docker build, Docker push, kubectl apply every time I change a line of code. So that should be automatic. I want a short feedback loop. I shouldn't have to wait, 30 minutes for CI to see if my thing worked or not. I want tools that don't get in my face. Hopefully, I'll get hot reload, which is the ability to, when I change my code, I can either rebuild that container and redeploy it, or I can just change code inside the live container without destroying the whole thing and starting it again. It should also be easy to onboard. And when I mention, populate a database before a service starts running, that's a dependency. So it's one thing that depends on the other. And ideally, I should be able to write that down and have it run automatically instead of having to remember that, oh shit, it doesn't work right now because I didn't put the tables in the database. I also I like to run tests as I write my code, not half an hour later in CI. I like to, I save my file, my tooling is going to rebuild my stuff, it's going to redeploy, just run some tests as well so that I know that I didn't break anything important. Ideally end-to-end tests, but and when it comes to debugging, it's important to be able to stream logs from many different pods, many different places in my cluster. It helps if whatever is wrong with those logs is highlighted. And something that I missed for a long time was being able to use an actual debugger like GDB on applications running in containers. So we're going to look at that too. and we're going to look at distributed debugging, which is super cool. And we're not going to talk about tracing, because that involves changing your code, and it has performance concerns to your application, so that's a different conversation. So this talk is going to be very fast. We're going to look at lots of tools. I would recommend that you try to focus on see what catches your fancy and then do some research later. There's no time to go in depth on all the tools. So I'm going to show you a big bunch of stuff. And at the end, I'm going to show you, for these kinds of things, you should use these things. For those kinds of things, you should use those things. All right, so let's get started. And I'm going to open my water bottle here. Okay, so I split all the tools that we're going to see into 3 categories. Debugging, which is, debugging. Then deploy and extras is basically when you want to do stuff with the pods inside your cluster, or either connect the stuff on your machine to your cluster, or connect your cluster to your machine, that kind of stuff, but it's a more hands-off thing. It just connects things for you and you do whatever you want. And then the build and deploy cycle is that thing where you write your code, you save your file, it rebuilds, it redeploys, you see the changes live in your cluster. So these are the tools we're going to look at. These are by far not all the tools you're going to find in this landscape. There's tons of others. And fun fact, I put a fake one here. Can you spot it? And if I missed any cool tools, by the way, that you really like and you think I should have talked about, please let me know. This talk is going to be a living resource. I'm going to put it on a website, a repo or something, and keep it updated. So if you want to contribute to that effort, please get in touch. And okay, so let's try and revert this situation by a tiny fraction. The first debugging tool that you're going to use is kubectl. And you can't see kubectl's logo. It's tiny. I made it tiny because it's scary. That's a cuttlefish. It's really scary. So look at it for a second. I'm going to have it. So kubectl is it's a tool that you need to know. You need to be familiar with. You need to know how to see if your pods are working, if your stuff's running, how to change things, how to kill things, how to destroy a namespace because that project sucked anyway, all of that. I really hate that developers need to be familiar with kubectl, and this is coming from someone who has merged code into kubectl. Kubectl is great, but developers shouldn't have to use it because it's like going to your kitchen and every time you want to, get some water on the sink, you need to fix your plumbing. To me, that's wrong. And unfortunately, right now, getting water from your kitchen sink is a better abstraction of the underlying infrastructure than Kubernetes is for deploying your code. So yay for centuries of plumbing tradition. So just learn to use the basics of kubectl. If you're going to take nothing away from this debugging section of the talk, just memorize this one command here. It's going to stream logs from your pod. You can just fill your code with printfs, and there you go, debugging. If you want something more sophisticated than that, oh, by the way, this is one of the documents you should read to get familiar with debugging with kubectl. There's a link at the end. You can get all the links later. So let's look at something a bit more fancy, Squash. Squash allows you to attach a debugger to your to a running container. A debugger, I mean GDB, Delve, the node container, the node debugger, whatever it's called, and those things. You can use them with an IDE or a CLI. And the cool thing is you can attach multiple debuggers to multiple containers at the same time. So you can have 2 services that talk to each other. You can have that interaction happening line by line as you step through your debugger. You can have breakpoints. It's amazing. It's like mind blown when I first used it. Here's what it looks like. So first I tell I'm going to use Delve as my debugger. I choose my namespace. I choose my pod. Here at the bottom is just a normal debugger. Here I'm setting a breakpoint. And if you've ever used a debugger before, from now on, you know how it goes. So this is super cool. And my super favorite, best tool ever when it comes to debugging is Stern. Stern streams all the logs from all your pods from a namespace or from however you select it into a single console. It's very simple and easy. It does for multiple pods at the same time, so it's better to use than just the kubectl version. It's super easy, super simple. I always have it running when I'm working Kubernetes stuff. And so every different color here is a separate pod, and you have all your stuff in one terminal, and that's great. Okay, next session. Deploy. So this is stuff that's going to allow you to connect to your cluster or have your cluster connect to your machine. It's hazy, and then you can play around with it. So the first one is Forge, and one important thing to talk about Forge is that it's dead. It's not under development anymore, but we need to talk about it because it was a key player in this area. According to someone who works at DataWire, you can think of it as a fancy shell script that does docker build, push, and kubectl apply. So it doesn't watch your code, you have to call it yourself, but then it does all that cycle for you. You need to have all your Kubernetes YAML, you need to have your Docker files, and then it just gets things running. So it was a good effort, too bad it's discontinued, but yeah. Okay, so next thing, Helm. Has anyone here not used Helm before? Okay, that's a very tiny fraction. For those ones who raised your hands, just learn Helm. It's omnipresent, it's everywhere. You need to use Helm. You are going to use Helm at some point. I don't care if you hate it, just, suck it up. That's life. So Helm is a package manager for Kubernetes. So basically you can do Helm install WordPress, and voila, you have WordPress in your cluster. The way you're going to use this for local development is you can write some code, you can wrap this code as a Helm package, and then install that to your cluster. So that's an alternative. Usually, it's a bit clunky of a workflow. You don't want to do that, but you need to be familiar with Helm anyway. So, yeah. Okay, ksync. Now things get more interesting. Ksync syncs files from your local file system with a file system inside your cluster. So you want to change something inside the pod that's running. There you go, ksync. You can do it. It doesn't do anything besides syncing the files. So if you want something to happen after you sync the file, you need to write that in yourself. You need something watching the file system of your container for changes, and then you do something from there. It's a very simple tool. It does one thing, and it does it well. You should get familiar with it. Okay, next one. So KubeForward. KubeForward, it forwards all the stuff, all the parts in your cluster to your local machine. So this diagram explains it better than I can. Basically, you have ways that you can access that your pods can access the other pods in your cluster. With KubeForward, you can access them the same way, but from your local machine. So you can develop your application locally, like even without Docker, just like an executable running on your computer, and it's going to connect to. It's going to be able to talk to stuff in your cluster, and that's super useful in some scenarios. I use it a lot for debugging as opposed to for building stuff. So, something is not responding, I connect it to my machine, send it some weird-ass API calls and see what happens. Okay, so that's KubeForward. Now, Octeto and Telepresence, I kind of have a hard time telling the difference between the two. So what they do is they take a pod inside your cluster and they kind of do a switcheroo in that pod, and they replace that pod with something else. Octeto replaces that pod with a development environment. That's what they call it. I don't really know the precise details, but basically it syncs files. It gives you a terminal that is inside that pod. It does port forwarding, that kind of stuff. And this is kind of what the next tool, Telepresence, does. But the thing is, with Octeto, your code is running inside your cluster. With Telepresence, you bring the stuff from your cluster to your machine. Kind of. I'll explain. So the thing about these two is they only work for one pod at a time. So if you want something that's for you to work on all the components of your app at the same time, this is not going to work so well. But they're interesting things for certain tasks, and you should look into them. So Telepresence, what it does is instead of your stuff running inside the cluster, it forwards all the network from your cluster, from that pod into your machine. So you have a shell on your computer where all the network activity is going to think it is inside the cluster because it's all proxied through. You can use your IDE, you can use a local debugger, all the stuff that you like to use locally, but all the network activity gets proxied into the cluster. So that's super cool. I mentioned the debugger. So when would you want to use Telepresence in a local debugger versus Squash that uses the debugger on the run in container? So there is like some, technical nuance that I'm not familiar with of like, if you're running Docker locally, it behaves differently than whatever different Docker versions in your cluster. Something crazy stuff I don't really know. But to me, the main thing is with Squash, you can attach debuggers to multiple services at the same time. With Telepresence, it's just one. So to me, that's the main distinction in my mind. A lot of people use Telepresence. It's a widely known and used tool. If you're not familiar with it, it's worth a look. And finally, my favorite section here, and I'm going to talk a lot, so I'm going to take a sip of water again. Okay, so draft. What this draft has in common with Forge, the fact that it's dead. Development has stopped on draft. I'm not sure if that's permanent or not. Developers from the team that was building draft have moved on to other things. And draft does that thing I said before, where you change a file, it's going to detect that you changed the file, it's going to rebuild the container that thing is in, it's going to redeploy that stuff to your cluster, and then you can see your live changes right away. So it's a tool that focuses on doing that. It can generate config files for you, so that's great. Like if you're kind of a newbie into this and you don't really have templates for these config files or don't really know how they work, I'm not sure which config files draft generates. I know it generates some config files. So if that interests you, look into it. And so draft, when it came up, it did the job. It's a good thing. It has some drawbacks. So, for example, it won't put all the services in your cluster up at the same time. You need to go into each one and manually go draft up in each one. So that's kind of annoying. And draft doesn't do hot reload, which is the ability to change files inside the live container without redeploying the container. So all the other tools we're going to look here, they do that. Draft doesn't. Okay, next tool. Oh, wait. So here's a screenshot of draft. At the top, I have just a few files. Then I do draft create. It generates a bunch of config for me. I do draft up. It builds the stuff, puts it in my cluster. Now it's all up and running. And then draft connect, and I can make use of that thing that's now running. Okay, next one, Garden. I work for Garden, so of course it's the best tool of all, and you should all use it. And go to our repo and give us GitHub stars, and go to our channel on Slack and tell everyone how great it is. Okay, the sales pitch is over. The cool thing about Garden, compared to the next tools that we're going to talk about, is you don't need Kubernetes manifests. If you want to do kind of a Ruby on Rails kind of a deal and have it just choose things for you and it just works, you can do that. If you have your own specific manifest that you need to use, you can use those as well. That's fine. But it's cool that, like, if you're a beginner in programming for this kind of stuff, you kind of can just push those things away and not worry about them for a while. Another cool thing that Garden does is it allows in-cluster builds. So like everyone has had trouble with Docker on their machine, or Minikube not behaving, or you had an old version of kubectl and suddenly nothing works. So if you don't want any of that, you can just write the code on your machine. Garden syncs the code every time you save a file into the cluster. All the builds happen in the cluster. You don't need Minikube, you don't need Docker, you don't need kubectl in your machine. So that's really cool, and it's also really fast, because sometimes building Docker images, depending on what you're doing, takes a long time. You put it on a beefy cluster with all the compute power in the world, and it's kind of instant. So that's super cool. You can even use like a 10-year-old laptop and have a super snappy experience, which feels weird, but it's a thing. So, all right, and the main difference from Garden to the other tools is that all the other tools in this category are very focused on just that development cycle. Change a file, rebuild, redeploy. And Garden has sort of project awareness, in which when you set up Garden for a project, you declare the dependencies, the build dependencies, and the deployment dependencies for each service. So remember that thing about, you need to populate the database before the next service goes online? With Garden, this is trivial. It's obvious. It's Garden's bread and butter. Garden also has tests. So you save your file, it builds, deploys, and it runs the tests that you want it to run. And these tests are also in this dependency chain. So if you have 100 tests and you make a change to this one service here, it's only going to run the tests for this one service. It's not going to run all the tests. So it's not like CI where running the test takes forever. It's very snappy, it's very quickly, because it only runs the stuff that it has to run. And you can configure tests to have multiple services as dependencies, and then these tests would be integration tests, because you can have a bunch of services talking to each other on every test you run. Garden's also pluggable, so you can have custom modules for containers that behave differently, let's say special containers. So for OpenFast, or if you have some crazy Java workflow that needs Gradle and Maven and whatever you Java people do, you can configure those as well. And okay, so this is what Garden looks like at the top. This screenshot is I ran the Garden console against a service that was already running. So the tests had already passed before, they were cached, the services were already up and running, so it's kind of not a very exciting screenshot, but this is what the CLI looks like. Garden has a dashboard that tells you some info about your services. It has that dependency graph of your whole application. And if you look here, you can find DB in it. That's the one I've been using as an example the whole time. So after you initialize your database with the tables, then the Java worker runs. So that's a thing. And when you break something, when a test fails or when some config goes wrong, something like that, it shows you right away. Okay, enough about Garden. Next tool, Jenkins X. So a lot of people love this tool. I had trouble placing it here in the talk because of the scope, because Jenkins does something about provisioning that I don't really care about. It's outside of the part of the day where I'm writing code. It does something about CI, which also I don't care about when I'm talking about this subject. And the part that Jenkins does that I do care about is basically Scaffold and K-Sync in the background. We already talked about K-Sync, and we're going to talk about Scaffold next. So I don't really have much to say about Jenkins. If you're using Jenkins for all your CI stuff, I guess that's great. So you can just use Jenkins X for this workflow. If not, then I don't know. A cool thing about Jenkins is it has build packs, so it's kind of like a draft in which it can generate config files for you. It automates, like you just give it your code, and it, magic, and now it works. It can do some of that, but I didn't really look into it. I should, so, well. If there's some Jenkins people here and you want to enlighten me, there you go, let's talk. All right, so I said Jenkins uses Scaffold in the background, so let's talk about Scaffold. Scaffold is a tool that really focuses very narrowly on the change your code, rebuild, redeploy, end of story. It's very focused on that. It's really good at that. And its strength is that it's very simple. If you have your Kubernetes manifests already that you set up in some other occasion, running Scaffold is a breeze. It's very easy. It's like basically out of the box. If you don't have your Kubernetes stuff all done already, then you're in for some trouble because it's not going to help you with that. So if you're like a total beginner, maybe you should try Garden first or Draft or something like that. So Scaffold, it's very fast. It's very simple to set up once you have your manifests. This is what it looks like. So I start Scaffold, it builds my stuff, it puts my stuff in the cluster, and here at the bottom, it's the output of my application. I make a change, it rebuilds again, redeploys again, and now I have an extra exclamation mark, which is always fun. Okay, so that's Tilt. It's pretty simple, that's Scaffold. Pretty simple, pretty straightforward. So now we're going to talk about Tilt. And the thing about Tilt is it's basically one-to-one feature-wise when compared to Scaffold. So all the things that Scaffold does, Tilt does kind of exactly the same. It has a few extra bells and whistles, but it has the same focus. The one difference is that Tilt is gorgeous. It's really good looking. It's really slick. I really like using it, even if I don't have to, just because it's like, whoa. Like the CLI app, it's great. The dashboard's great. It focuses a lot on logs, events, on errors, on making sure you know what's happening within your application. And so like if you use Skaffold, if you're thinking of using Skaffold, just use Tilt instead. It's so pretty. So I kind of messed up the screenshot here apparently, but this is a deployment in progress. So at the top you can see some things are running, then a container is being built or generated or whatever, and some things are still pending. This is the CLI. It's really slick. It's glorious. The dashboard is also super pretty. It looks like a chat room. It is not. Those are all your pods, not all your friends. You know, sometimes they're and when something goes wrong, it pops an alert, it tells you right away. So it's really good to keep an eye on things, and it's just a pleasure to use. Okay, so we've reached the end of going through every tool in the world, and it's time for a water break again. So now we have a bunch of tools at our disposal. So how do we organize this? Okay, so first Helm. Helm is everywhere, it's omnipresent. If you haven't used it, lucky you, you're gonna have to, sorry. Unless you like it, then yay. So for tools that do the whole build and development cycle, and we have 5 of them there, I don't have much to say for Jenkins because it uses Skaffold in the background, so let's just talk about Skaffold instead. Draft is dead, so let's not talk about it. Between Skaffold and Tilt, I would just use Tilt because the user experience is so much better. And then it's between Tilt and Garden. So we've had users come to us and say that they use both in their companies. In that case, the user I have in mind, it was Skaffold and Garden. So the way they would separate would be like, if I have all my Kubernetes manifests and I want to do something quick and easy to set up and just get it up and running so I can do this one thing real quick here, then I use Skaffold. If it's a more complex project that I'm going to work in depth with, I want those to track those dependencies. I want to run tests. I want in cluster builds. I want all of those extra features, then I use Garden. So Garden requires you to learn some new concepts on top of the usual Kubernetes stuff, and it brings a lot of advantages, but that's a cost. On the other hand, with Tilt and Skaffold, basically you just bring your manifest and it works out of the box, and you don't have to worry about anything new, or it's going to just work. So you have to choose for each project whether you want more convenience or more something that's more encompassing and that gives you a more in-depth, that takes care of your project in a more in-depth manner. Okay, so deploy. These are tools to just go inside your cluster and play around with it, and it's not a workflow as opinionated as the workflow before. So Octeto and Telepresence. I think it really depends on whether you want something that's going to run in your cluster or whether it can run on your machine. It's easier if it's running on your machine. I personally haven't used Octeto myself. I hear good things about it, but I don't know. And then we have Ksync if you want to just change files inside a running pod. And we have KubeForward if you want to poke at all of your cluster's endpoints from your machine, or you're developing that first prototype of something that's going to run on a pod eventually, but right now it's running on your machine, and it needs to be able to talk to the pods in the cluster. Lastly, for debugging, I suggest you just learn all of them because they're great. So Stern is awesome. You don't really need Stern if you're using Tilt or Garden because they do a pretty good job at log streaming. But for everything else, you do want Stern to be running at all times. Then Squash is basically, are you a debugger person or a printf person? So if you're a debugger person, then you want to use Squash. And KubeForward, already mentioned it before, it's really useful to be able to poke at the endpoints as a way of debugging. So that's what I had to share. Those are all the tools. This is going to be a living resource, something that I want to keep updated so that people can keep referring to it and keeping track of, okay, I'm a developer, I need to do X or Y, which tools should I use? So if you want to contribute to that, again, please get in touch. What is still missing from this picture? One, better docs. Preparing this talk was painful because the docs are terrible. And I mean, I didn't have to read the Garden docs because I worked there, so I don't know if the Garden documentation is terrible, but a lot of the documentation was really bad, and as a collective of developers working on this, it's something we should really focus on. Better support for tests is something that I really wish were more widespread. So many tools, you know, they rebuild your stuff, they redeploy your stuff. It costs nothing to run some tests as well. So the text got kind of put out of place here, but this would be a way to just run tests. So you just pass a list of files to this little application called ENTR. It monitors your file system. It runs a script every time something changes. It's that easy to implement tests every time you make a change. So, you know, let's just do it. Something else that's missing is beginner friendliness. There's a lot of jargon when studying this stuff, a lot of jargon. It doesn't help anyone. Consistent naming for same stuff across different tools, I also wish were present. So hot reload, live reload, file sync. There are 10 different names for the same thing throughout different tools. That doesn't help anyone. And to finish this up, what I miss the most when preparing this talk is clarity. It's a cohesive story. I'm a developer. I'm trying to do X. Which tools should I use? Or I'm trying to do Y. Which tools should I use? I think I'm helping this landscape by preparing this talk just a little bit in this area, and I hope it's going to get even better in the future. So these are the links for all the tools I talk about. I'm going to share the slides on Twitter in a few minutes, so if you want to, you know, check it out. And let's end with, you know, glorious few words by a great friend of mine. You can't have a clusterfuck without a cluster. So that's it, and thank you.
Thank you very much.